Page 149, number 10. The formula for the volume of a cone is V is equal to 1/3 pi r squared h. And there we have a picture of a cone, and you could see in that picture you could see that what r is this red line over here, and h is the height. And r is the radius of one cross-section of the cone, a circular cross-section. Find the rate of change of the volume if dr dt is 2 inches per minute and h is equal to 3r, when r is equal to 6, and when r is equal to 24. Okay, so first let's see what the problem is telling us. Well, first of all, we're asked to find the rate of change of the volume. So we want to know, we're asked to find dv dt. Okay, so we want to know what dv dt is. And we're told that dr dt is 2, so the radius is increasing. Alright, so the radius is it's sort of expanding, it's getting wider, the cone is getting wider. The radius is increasing at 2 inches per minute. And we have a relationship between the height when the increase takes place. The height is always 3 times the radius, so the height's also going to be increasing as the radius increases. So we want to know what dv dt is first when r is equal to 6. Well, in order to use this information, and in order to find dv dt, we're going to have to differentiate this formula. We're going to have to differentiate the formula for the volume with respect to t, like we always do in these related rate problems. All the variables are increasing or decreasing, changing with respect to t, and we always differentiate with respect to time. Okay, if we differentiate the formula as is, then on the right hand side we have two variables, these two factors, r squared times h, and we're going to have to use a product rule here. So let's avoid that by first eliminating one of the variables. We'll substitute in using the relationship that we're given, that the height is always equal to 3 times the radius. Okay, so let's do that substitution. Now when we do that, we're going to get rid of the h variable and we'll be left only with the r variable, which is good because we're given dr dt here, and we'll be able to substitute in dr dt is equal to 2. Alright, so we'll start by using this relationship and eliminating h. So the volume is equal to 1/3 pi r squared, and instead of h we're going to put the quantity 3r, because h is equal to 3r. Alright, let's simplify that. These 3's cancel, see? Okay, and we get that the volume is equal to pi r cubed. Okay, now let's differentiate with respect to t. Alright, so we have dv dt is equal to pi times 3 r squared dr dt. Okay, so now we're ready to substitute in. First of all, dr dt is constantly 2, so we'll substitute in a 2 over here for dr dt. And we want to find out what dv dt is when r is equal to 6. Alright, so let's sub r equals 6. And dr dt is equal to 2. And we get that dv dt is equal to 3 pi times 6 squared, that's 36, times 2. That's 3 times 36 times 2. That's 3 times 2, that's 6 times 36. So that's pi times 180 and 36. So that's 216. Or 216 times pi. Alright, so that's the volume, and the volume is a three-dimensional measurement, so that would be cubic inches per minute.